All right, continuing on page 3 of ChemQuest 27. Can you determine a molecule's molecular formula solely from the percent composition? Sometimes, but not always. For example, on the page before, we noticed that C6H12 and C3H6 have the same percent composition, but they have a different molecular formula. So I will use, for example, C6H12 and C3H6 had same percent composition, all right, but different molecular formula. They do have what's called the same empirical formula, which is the ratio of elements. So C8H8, this is we know that there's a 1-to-1 ratio, so the empirical formula is going to be CH. And therefore, without doing a calculation, I know it's going to be the same as these ones that were like C6H6, because they have a 1-to-1 ratio, like benzene and cyclobutadiene. So it's going to be the 7.76% and the 92.24%. Because I already figured that out when I did those other ones. The C10H20 is going to have an empirical formula of CH2, which is exactly the same as the hexene and the propane. Those also had an empirical formula of CH2. So I know it's going to be 14.4% and 85.6%. An empirical formula is a formula that describes the lowest whole number ratio. All right, in this example is CH, which we've already talked about in class. Here it says, what is the empirical formula for a compound whose percent composition is 92.2% carbon and 7.8% hydrogen? This looks just like this one up here. This was 7.8% and 92.2%. So I know the empirical formula is going to be CH because it's exactly the same. Now it says verify that the empirical formula for hexene is CH2. Well, hexene, remember, was C6H12. And so C6H12, essentially you're finding the common denominator. We divide both of these by 6, and I get CH2 because there's a 1-to-2 ratio of carbon and hydrogen. And then in the rest of this page, we're going to talk about how to calculate the empirical formula if you know the percent composition. So in order to do that, if you know the percent composition, the first thing we want to do is essentially, I like to say, assume that you have 100 grams of compound. And so that's why we're going to divide it. We're going to assume that we have 100 grams of the compound. And if we have 100 grams of the compound, 30.4% would be 30.4 grams. And 69.6% would be 69.6 grams. And what we're going to do is divide them by their molar masses in the periodic table, which gives us moles of compound. Once we know the moles of compound, we're going to then divide it by whatever was smaller. In this case, 2.17 is the smaller answer. So I know that if I have 2.17 moles divided by 2.17, I have 1. Here I have 4.35 moles divided by 2.17 I get approximately 2 moles of oxygen and 1 mole of nitrogen. Therefore, I know my ratio is 1 to 2. And so I'm going to use these as the subscripts. And again, there's an understood 1 right here. We actually don't write the 1, do we? All right, so that is page 3 of ChemQuest 27.